Assalamualaikum and very good day to you all. In this video, we are going to present about the product life cycle of mountain bike. We are from group 22 from section 2. Our team consists of 5 members. For the introduction, sustainability acts as the main rule to ensure that technology development will not affect the environmental or earth. In this study, we are focusing on 6 innovation elements in the sustainability field, such as remanufacture, redesign, recover, recycle, and reuse.
For background study of this project, requires students to choose one product that consists of a minimum 15 components or parts. The product decided must be a mixture of metal and polymer parts. So our group decided to choose a bicycle as a product. A bicycle has 28 parts or components that consist of the major and minor parts. The objective of this project divided into 3. The first is to perform a comparative assessment of a manufactured bicycle life cycle. Second is to design and develop a bicycle that has sustainable manufacturing value. And the third is to consider all the environmental impact, as well as to indicate area of the bicycle that can be redesigned to improve its environmental sustainability. In literature review, we found that according to Thakur and Babu 2019, the most recent bicycle technology was developed to help regular bicycle users develop their influence on physical fitness. Bicycle has become the most eco-friendly fitness equipment in the world today, since technology has had a large influence over the design and use of bicycles. According to Baumer Cardozo, green manufacturing can be beneficial for the environment and for the business as well, because it keeps the business in a positive space in terms of the corporate image, which has toward environmental stability. Hochschild also stated that firms that use the FE method get to improve the environmental performance of product by reducing the cost, boosting competitive advantage of their companies, and stimulating innovation. The FE process involved in designing products that use fewer resources, less packaging, and environmental friendly material. The FE also focus on designing the products that are able to be recycled, reused, and remanufactured.
So now I will explain the methodology. The product life cycle is the process that a product goes through from the time it is initially presented to the market until it is discontinued. There are 4 primary stages in the product life cycle. The procurement of raw material and resources needed is part of the resource phase. During the growth phase, the product is created using various machining process in accordance with the process product design. The final step, often known as the decline phase, denotes the end of product life cycle. Eco-design is a pillar of the circular economy, a concept aimed at giving items an unlimited life cycle within a sealed, waste-free loop. The structure of eco-design can be divided into 5 main parts, which is the material, manufacturing, use, end of life, and transport. The eco-indicator approach expresses the impact on the environment as a value or a grade. The eco-indicator of a substance is a value that shows a material or process environmental effect based on information from a life cycle analysis. The stronger the environmental impact, the higher the indicator. According to Beiser in 2016, the term environmental harm is classified into 3 categories by eco-indicator. First, it comprises the amount and duration of disease as well as the amount of life years lost owing to environmental degradation related death, such as global warming and depletion of ozone layer. Next, the influence of species diversity, acidity, ecotoxicity, and land use are all included in ecosystem quality. The number of species that have been extinct in a specific area owing to environmental load over a specific period is used to measure harm to ecosystem quality. Lastly, the decrease of raw material and energy supplies falls into this category. It is calculated in terms of the additional energy necessary in the future to obtain lower quality energy and minerals.
For a result, first, product planning. We implement product planning to overcome the problem in reducing the environmental impact of new byproducts. We identifying sustainable requirements that define a product future. It serves as the basic for the decision making. This is our product planning focus on the design of the environment, DFE. You can see it here. Now we go to design option. This design was chosen as our product. This selection is made through several criteria including LCA and the FMA. 15 bicycle part as the main thing in the implementation of this product. We record the value of eco indicator 99 on the 15 part of the bike. Example, handlebar, brake lever, brake cable, fork, and rim. Now we go to product life cycle of mountain bike. This sketch has been done based on the product life cycle strategy. Now we can summarize the product life cycle here. You can see here from source, manufacturing phase, use phase, and of the life phase. Now we go to the process tree. This process tree for a new mountain bike, between its origination and disposal, a product goes through process such as manufacturing, assembly, distribution, installation, operation, maintenance, use, reuse, and dispose. So, you can see that process happen here. Okay.
Next, the comparison of eco-design web before and after redesign. The first stage is the new ways of doing it. In this stage, the new design introduced new ways, which is the mountain bike is now lighter in weight and the speed also increased. The bike is now more agile, more comfortable to ride, stronger and more durable. The scale in the eco-design web also changes from okay to very good. The next stage is the material selection. The material selection in both design of mountain bike remain the same. However, the scale of eco-design web changes from bad to good because the quantity of materials used in the new design has decreased. The third stage is the material usage stage. In this stage, the manufacturing process of the product is almost the same and the number of parts also remain the same, which is 50 parts. Therefore, the scale of the eco-design web is also remain the same, which is good for both old and new bike. The fourth stage is the distribution. The packaging of the product is from local manufacturer and the product is distributed by Taiwanese manufacturer to Malaysia. The eco-design web scale for this stage remain the same, which is okay. The product use is the fifth stage in the eco-design web. In general, this product is mainly used as a transport that did not consume any fuel usage, which is very good to the environment. The eco-design web scale in this stage changes from okay to good. The sixth stage is the optimal life stage. The new bike has 5 years guarantee. It is now easier to repair and the product usage does not require any power supply. The scale of the eco-design web for this stage also changes from okay to good. The last stage in the eco-design web is the end-of-life stage. After disposal, the parts are either landfill, recycled or reused. The scale of the eco-design web in this stage changes from bad to very good. In conclusion, the overall size of the scale in the eco-design web become bigger after redesign because the impact to the environment from the production of this product has decreased and now are higher in environmental sustainability. Next is the comparison of eco-indicator before and after redesign. The eco-indicator of a material or process is a number that indicates the environmental impact of a material or process based on the data from a life cycle assessment. The higher the results of the indicator, the greater the environmental impact. The result of production in eco-indicator decreased from 1100.59 to 915.47. This is because the design size of the mountain bike has changed to an optimum size, which is smaller after redesign and thus reducing the amount of material used. The result of use in eco-indicator remain the same, which is 34.59. This is because the usage of the mountain bike is already in a good condition and there is not much improvement can be made. The result of disposal decreased from 25.31 to 9.19 because the disposal of the material is more sustainable after redesign and most of the material can be disposed properly. The overall results of the eco-indicator decreased from 1160.05 to 959.25. The decreasing in overall results of eco indicator shows that after redesign, the production of the new mountain bike impact less to the environment.
As a result, the life cycle of a bicycle is determined using comparative assessment, which consider all conceivable factors in this study. A new bicycle design and development has also been developed to ensure the long-term viability of the manufacturing value. In other words, recycling the bicycle components at the end of its life cycle also saves money in terms of emission and fuel usage. Environmental consequences in this study can also be reduced by employing appropriate approach assessment, such as design for environmental.